My name is Brianna Curl, and I'll be your moderator for today's webinar on Accelerated Devices Journey Continues, Manufacturing Production Meets Scheduling. If you have any questions throughout the webinar, please type them in the questions panel as they come up. We will have representatives ready to answer questions directly during the webinar. This webinar will be recorded. Today, our webinar is presented by EMA Design Automation and Dassault Systems. EMA is a Cadence channel partner and a leader in product development solutions. And Dassault Systems provides businesses and people with a virtual universe to imagine sustainable innovations. With that being said, I want to thank you all for joining us for today's webinar and introduce you to our presenters, Ed Clark and Lou Feinstein. Ed is a business development director with EMA Design Automation, and Lou is with Dassault Systems, focusing on global management of high-tech solutions within the Dassault Systems portfolio. Assuming we have time at the end, we will send some questions in a formal Q&A. And thank you for your attention. And now over to you, Ed.
Great. Thank you so much, Brianna. And I'd like to say also thank you to Lou, and EMA is very excited about being a partner of Dassault Systems. So this is the third instantiation of our Accelerated Device series. So this one's being first to market and has to do with manufacturing. But you can see the HTTPS there, the link to the other webinars that we've done. There's also some great information there on design engineering and product governance. So with that, we'll get right into it. I will kind of go over, and Lou, we're tag teaming on this. Thank you, Lou.
Oh, no worries. Thanks, Ed. Thanks, everybody. So this is interesting, working with EMA on this, because for years EMA has really been one of the primal companies, or primary companies that I've gone to for years for ECAD solutions. And now we're going to talk about taking those solutions that we do for ECAD and going way beyond design and engineering. We're really going to move it into the manufacturing side of the business. So I'm very excited to be working with EMA on this. So what we're talking about is manufacturing process engineering challenges. And when you think about it today, and they really substantiated themselves during COVID-19, is really, demand planning, supply volatility. And then the other thing we're seeing is mass customizations in manufacturing. People want to have their solution of the size and shape and color that they want. And basically, it's a global world of production and distribution. So it's no longer being done at a single site. You might have multiple sites. And what we're trying to address here is really some of the questions we have on the right side is, how do we handle the increasing number of, product models and variants? How do you handle increasing product complexity? Validating is the product manufacturable? And we'll talk a little bit about using a virtual twin to actually set up and look to see how you put your product together, and at the engineering perspective, and then how to ensure products start production despite an aggressive timing. That's the number one thing. Everybody wants their product to go to market as fast as you can, and it's really sometimes really hard. And how do you handle change management effectively, and once it's hit manufacturing, and how to achieve the manufacturing process and manufactured product right the first time?
Great synopsis of all the process engineering challenges, Lou. And what happens there is we have this great digital divide, this great chasm, and on one side you've got the engineering tools, and companies don't care about engineering tools whatsoever, other than an end to a means. What companies care about is products and getting products to market. Designing those products, as I have and as Lou has for many years, we're design engineers. That's what we do. We use the authoring tools on the engineering side. We create schematics, and we validate that product that's going to work in the environment that's going to go in. But then when it comes to manufacturing, we basically throw it off the cliff, just like that person is taking the step into the chasm, or we're basically throwing it over the wall and saying, okay, production, manufacturing, you figure it out from there, and let us know if something doesn't, we validated our stuff on this side. So the big thing that we're really looking at now is being able to plan, being able to visualize and validate, that gap that's in between. In our case, we've had this digital manufacturing, this product engineering, and product production, separated by this chasm that we talked about. Now we have this digital manufacturer, this way to do process planning. Creating the digital twin, as Lou mentioned earlier, and being able to validate those assemblies and that process that's going through there. Being able to create work instructions and really shorten the time that it takes to people to learn to assemble the process and make sure that the process is very well defined when it comes to comes to the factory. So this is one of the things that we had talked about, is crossing that chasm. We're very familiar with the design process, and then we'll throw that kind of design over into manufacturing. They create a definition. Well, what if you had the capability of visualizing that, doing a what if of what if I move this workstation for this product a little bit closer to the next step in the process. What if I had better process planning? Everybody can have a plan, but plans always become obsolete very quickly. So the process of planning and validating that process and visualizing that in a way that can be optimized is key. We mentioned before work instructions. Getting those people to condense that time that it takes them to figure out how to effectively process and move things through the assembly line. And then when it comes to distribution, planning the approvals for agency approvals and distribution, it really there really needs to be a feedback loop there, and with our process and this digital continuity, there really is. And we've got a short video actually to show how some of the mechanical or manufacturing bill of materials, and we can get that from the engineering bill of materials. And Lou's going to go over that for us.
Well,
today.
This can be from mechanical or electrical, because we can connect to the ECAD solutions and MCAD. What's interesting about it is, all the people that have been doing making manufacturing bombs with their highlighters and crossing out two bills of materials. Sorry, we've taken away your job and actually made it digital. So what we can do today is we really can take the bill of materials from the engineering side, and we can actually, very simply drag and drop the different components into the manufacturing side and create a bill of materials. And what's really unique about it is that we can also include make or buy decisions. We can also include other types of structures to modify this. And what you're seeing down in the lower left, which you can't really see because we have we have a tag marking it. As you take the different component, it actually shows it being from the 3D world from your MCAD, showing all the parts that are coming off. So it's really the real crest of what's happening here is we've taken away the laborious work that's required to create a mechanical engineering bill of materials, and it's all validated, and it allows you to take make or buy parts and such, and parts that you're receiving, and add other components such as, like, sometimes you add glue or fasteners and such, and it allows you to take both electronics and mechanical and put it together, so you can really do an electronics box build. So we can move on to the next slide, but the whole showing of this is to get rid of to modernize the divergence from engineering bomb to manufacturing bill of materials.
Yeah, that's a great process to really understand and be able to visualize, Lou, and that's kind of what we're talking about here is this manufacturing process engineering. It's a way to visualize and get a great overview to model, plan, and optimize, and using that digital twin to create those, and do that process planning, create the work instructions, and optimize that assembly process. It's really key. We talk about new product introduction, NPI, and NPI, it's either on time or and many times or oftentimes it's late. And what do you do to condense the time during this process to make sure that your market that your product hits market when it's supposed to? We visualize, we validate, and optimize the product, whether it's assembly or manufacturing, and in a lot of cases, the design process itself needs to be optimized as well, and things done concurrently instead of in serial mode. And then we'll execute on those plans and move forward and make things better as we go every day. I know Lou and the Dassault folks have have done this process with thousands of customers around the world, and the digital continuity is one thing that they're really experts at, right, Lou?
Oh, absolutely. What we've done is we've taken our rich history in doing automotive and aerospace and really moving it now into the high-tech and digital world and high-tech manufacturing world. And really what we're doing is we have the ability to, using the platform, is to literally look at the engineering items. And so it's more moving MBSE or model-based systems engineering and moving that into manufacturing. So when you think about it, we're really looking at manufactured item definition, and you saw me doing that with the bill of materials. Then you do process engineering, where you're kind of figuring out how the pieces to go. But once you have the pieces figured out, you want to look at validate your process steps. Are you going to think process steps going to be work? Is the factory that you're working with have the right tools to be able to do this? And then once we have that, we can optimize it and tell you how to do the best line balancing, so that basically we can optimize the manufacturing process. And then then right from there is, because we have the rich content coming from the engineering design, we can really simplify making process documentation. The days of taking Polaroids or taking pictures or taking snapshots of your engineering screens are gone, because we can do these really interesting process documentation and really change the way we do that. And then we can look at the process distribution. This is really for some of the bigger companies that have electronics on one side, manufacturing on, or traditional box build on the other. We can really look at multiple factories at the same time. We can integrate to the ERP system, and then we really specialize in manufacturing operations management and SSOP. And that's really where we start getting into factory management. But for the sake of today, we're really going to be talking about the smaller definition, really looking at the manufacturing engineering aspects. We can go very, very deep because of our lineage coming from the automotive world and many factories.
Yeah, that's really interesting. And I saw the feedback loop there too, Lou. So there's constant improvement and Six Sigma, process.
We're even looking at some new loops now that are incredible. We can look at the defects coming off of a surface mount line and understand if they are they defects being generated by the process or defects being generated by the design. So it's really closing the loop between the electronics manufacturing and the engineering, because a lot of things that take place in manufacturing are actually design driven instances. So we're trying to see how we can use some technology, and we are doing that to look at the downstream defects to understand what the impact is. One of the things that was one of the biggest impacts we see in this space is traceability, and it's part variance from manufacturer to manufacturer, and we can actually see that with the system. As you change a reel of parts on a machine, we can literally see the changes. So basically maybe the footprint wasn't designed right, or the parts really say that they're the same but they're a little bit different, so you need to optimize your footprint as you move between different alternate parts.
That's a great point, Lou, and that goes all the way back to the engineering guys that thought they had got it right from the get-go.
Oh, absolutely.
You had mentioned, what is the impact? How does it impact the business? How does it impact, the production, hitting the market at the right time? Improving the efficiency of the, manufacturing planning. And I always say planning, because there's a difference between, like I said, having a plan and doing the planning, because the plan is always going to change, or something's going to happen. So being very efficient and having the proper manufacturing planning is absolutely key. We'll go into it a little bit more about shortening the learning curve for the production workers, but we want to have that continual feedback loop between process engineering, manufacturing, and even design engineering. So those are some of the impacts. I think we have a short video here talking about the digital continuity and how that works in the process.
Absolutely. So when you're looking at the processes here, now we're going to show you a bunch of different processes, and this is all using the Dassault platform. Is we're really recognizing and looking at the way products are built. And what you're seeing here is a product structure being delivered in a manufacturing perspective. Each one of those is a work cell per se, and we're delivering the components in the 3D realm by representing them as multiple components that get put together. So that's how we create the bill of materials. And what we do is we optimize the product for tooling and such, so we can actually do a lot of different interesting things. And basically what we're doing here is we're building the resource structure of what the factory would look like. The first one you looked at was what the breakdown of the parts were. Here we're looking at the definition of it, and what we're doing is we're trying to optimize how the components go together with the resources you have within the factory, and to understand if you need to do some changes in engineering. The thing that's interesting about this is that you can do this anytime early in the engineering aspects of the product, so which is really, really unique. So you can see that we can really facilitate process planning, and basically because we're using, again, rich data, and we can take the digital twin, we can literally show you all of the components broken down, and then we can take it to a different level altogether, where we can assign machines and factories and robots. So if you have a NPI line or a production line, we can really, really super optimize everything, and we can really assess the resources you have. You know, how many workstations, how many tests you have, and we kind of create the digital twin of all that, and we understand how your product is going to run through, and then basically we can look at the resource planning, and then we can line balance and optimize the way you're placing. Now here we're creating some work instructions, again, because we have the rich data coming from engineering. We can literally show the operator how to put the part in. You see that the part goes in, and then it has to be moved forward. Then we realize when we're doing this is that there's an interference. So our tools are smart also during the manufacturing aspect. So this is something that was missed by engineering. So they can go back and request to have that part changed, and now you see that the part will fit back in. So this is really some of the super value you get out of having the virtual twin of a part. So it's the measure and fit up, measure twice, cut once, and basically using the virtual world. And there's no other way to find that unless you actually produced it or use these type of tools. And then right from here, it's very, very simple to create shop floor work instructions for that. So basically, what we do here, to really, close the digital continuity is we can involve manufacturing very super early in the design process, and they can walk through, or you can walk through with them and understand the design changes in the process while the product is very in the maturing state. It also allows us to create a better understanding of relationships between product resources and the manufacturing systems. And it really makes it easy to share relevant information to the downstream stakeholders, the manufacturing, the ERP and MRP people, and then improving the utilization of the resources by balancing the operations earlier in the process. So it's really about combining in the engineering phase, if you want to streamline your manufacturing, is to really understand how you can optimize your design to really be designed for manufacturability. And again, using the virtual twin has been super accepted, and a lot of people are finding things that they would never find until it's been actually in the shop floor. So we're really seeing a lot of customers moving that way. And the whole idea is to improve efficiency in the manufacturing planets. One of the key things that our customers tell us, we don't have enough time to fix the problem before the start of production, and we hear this all the time from our customers. Is that by using the product, what we call build-up visualization, you can validate your design and assembly prior to creating any physical builds. You simplify the material handling of different designs and design models. So one of the things that we didn't show you here is that we can take a factory, and if you have to have multiple configurations, say you have red ones and blue ones and green ones, or you have different memories and different stuff, we can actually put in those steps what it's going to take for you to line balance, to be able to handle your variance and your different configurations. And it allows us to do a huge amount of what if scenarios and what if analysis in a virtual world. Think about being able to take your product design, running it through manufacturing with all the different variants and stuff, and being able to figure out how is the best way to optimize your machines. And it's not just the SMT machines, it could be your line, because you have different color knobs, you have different bezels, different shapes, and how do you best optimize the floor layout you have, and how to best optimize the staffing that you're going to need to produce the product, and inventory holding levels.
Spot on, Lou. And when we talk about improving that efficiency through those digital twins, the planning and being able to visualize that is the key. Before that, it's okay. We'll set up the line. We'll run a prototype through and work out the hiccups there. And that may take a day. It may take a week. I mean, it's really variable, and there's no visualization. There's no digital twin. There's no validating that process until they're there. So that often results in delays and respins and going all the way back to engineering, which could effectively take weeks. But with this solution, we've got a plan. We visualize that. We do the what ifs, and we fix any assembly errors or misunderstandings, of manufacturing constraints, what they can do, what they can't do up front. So that allows us to deliver on time. What would 1 week or 2 weeks be worth to you, in your product, if you hit market earlier, for instance, around Christmas time, that especially now, nobody's going to the store, so everybody's buying online. So now you've got another week or 2 weeks of, or multiple variants of those products. That's another thing that I think resonated with folks on one of the first questions was, being able to do multiple products, different variants of products, whether it's color or, one has GPS and one has, pressure and other options that you would typically want for a product. So accelerating, that, first time right in that new product introduction is absolutely key. There's certain business goals that we want to talk about, identify early on. The sooner we identify those issues, the more we can have an impact on them. Overall, efficiency is going to be improved. We're going to reduce the costs and drive, if there is an engineering change, it's done earlier. The earlier it's done, the more easy it is to deal with it, and the lower the manufacturing impacts are.
Yeah, one of my favorite slides that we didn't include in here is the cost of errors on the manufacturing floor versus catching them in the virtual side. Every step in the process you move down, it's just another magnitude of cost.
Yeah, we used to use that in production when we were doing mill aero, Lou, and it was okay. If I find this in engineering, it cost a dime. If I find this in manufacturing, it costs $10. If I find this in testing, it costs $100. So, absolutely, and it's not a linear scale. It's really,
actually, with today's supply chain, sometimes you only get the handful of parts you need, and if you put them up on a product that needs to be engineered or re-engineered, the cost could be the actual value of the product, meaning that the product will never go to market, or the product goes to market too late. Absolutely.
And one of the things we had talked about was shortening the learning curve for production workers. People always say time is money. Time isn't always money. Time can't be recovered. Time is time, and that's one of the things that I think time can be condensed, or processes can be condensed, but time can never be recovered. And that's one thing that building these visual processes and creating these what ifs and being able to build these products up in a virtual environment is absolutely key. And then giving people the clear graphical work instructions. And some of the other instructions I've gotten from China and other places haven't been as good and clear, but having those clearly concise instructions for assembly and work manuals are absolutely key. And and like we said, we could have multiple views, and these views are coming from the engineering side of things. One of the things you were talking about, Lou, was having that continuum, or having the data that's readily accessible, and being able to feed that information through that continuum, to shorten the learning curves and reduce the time that it takes to get the product through manufacturing.
Well, what we see is most customers are like almost 100% utilization or reuse of the engineering materials. So that what happens is they don't have to create materials in the manufacturing side. So it's a huge time savings just in the engineering instructions alone. Yeah,
and that was one of the things that you had mentioned was and I'll read this, and I read it because I absolutely think it's 100% critical, and I hope people really take this to heart. But manage to efficiently build up and optimize a good manufacturing plan, and planning being part of that key word that comes in there. Having the what ifs and being able to build up those visualizations is absolutely key. So you take the plan and you do planning from that plan. It can be just a little bit of time before the production starts, but it gives you that capability where you can visualize, you can validate the process, ahead of time. Somebody's going from building, 30 products, an hour to 40 products an hour. It makes a huge difference, and that optimization is what it takes to really be efficient in your product rollout. So I'll just build up this slide real quick. But, first time right, we had talked about that earlier, at least alluded to it. there's a lot of different terminology that goes with first time right, correct by construction, correct by design, minimizing those risks. And Lou and I had mentioned earlier how much those risks cost later in the process, really start to increase exponentially. So, really the goal is to, early and often do your what ifs, to get the products to market faster, have a short video to actually kind of go over some of this stuff with a smart factory that Dassault has implemented this process and worked with, like I said, thousands of customers to make this process 100% accurate.
So what we're going to show here is really the plan, run, and optimize of the factory solution. And really, it's, as Ed has alluded to, planning is critical. So here you're seeing the product being decomposed into the workstations. It's really been done by the bill of materials, and you're seeing the virtual parts be coming apart. This particular product has a lot of different variants. So you're working on the exact same data, but with different variants, so that we can graphically show the variants in here. So here you're seeing a black, a white, a checkered, a plaid front, and we can really assign that to a configuration. And as we run down the workflow and do the work instructions, they can dynamically change based on the work instructions, so that you can have alternates and such. So what we're doing here is we're really setting up the system to say that they're equal. Now this is a typical how we show or we simulate work planning, or the planning part of it. We take a look at it. We build the Gantt charts based upon how you've dissected the bill of materials and how you say you want to put together. And then once it's all put together, we can play through how each product step going together. And you can see here, as we've added graphics to it to say that you have to be careful of this. You need to look at this. Don't do this. And you saw previously how we work on the other different pieces. And basically, what we really do is we spend a lot of time publishing and simplifying the publishing of the documentations to the shop floor. It's really important. Now, that was the planning stages. Now, we have some really cool tools. Now, how many people out there have what we call stand-up meetings? Well, we have what we call our digital 3D lean tool, and it's really designed for doing stand-up meetings in the factory, or we actually use them in-house also for regular pieces. And we really do what we create is a digital continuity by using the stand-up technology, where you can show the different product runs, the different margins you're doing. You can also add sticky notes and stuff to it as we go along. And really, our goal here is to master the production. And so we use the same system to publish work instructions that we get from the engineering side. So what you've seen is that we've planned it, we've run a simulation, and now we're going to optimize it. And you say, well, if I'm offshore, where do I need to optimize it and such? But the interesting part is it depends on where you sit in the factory. What we do is we can actually get clear information on how things are running, and then on top of that, we can actually connect to the equipment if necessary. In a larger company, we have what we call internet or IoT connectivity, and basically we can connect to the factory and really watch the production and watch everything in real time. We can also watch the information coming in from the subcontractors and contractors. So our goal is to really reduce the variance and reduce inventory levels, and anybody in the manufacturing side will totally understand where we're coming from here. We've been doing this for years in the automotive and aerospace and defense, and we've recently moved into the high-tech world with these solutions, but these are scalable. So don't be afraid if you're a small company, because basically you may not need to have the SSNOP stuff, but the virtual documentation and the ability of the other documentation is unmatched when you're handing stuff off to a subcontractor. And most likely a lot of your subcontractors may be running our solutions as well. But at the same time, it really eliminates it really eliminates a lot of errors that you see in the factories when you offshore, and it also helps with the communications with the offshore, because you can actually do work instructions if you have a specialized way of putting something together.
Yeah, we're really nailing this, Lou, when it comes to the optimization and the process. It really is important. Like I said a little bit earlier, what if you miss this Christmas online season? It's not gonna be like it was before. The dynamics of the industry has really changed.
What we've done is we've really changed the game too, because what we're doing is we're using ECAD and MCAD data. And so basically it's a game changer, because basically we look at the factory as a factory. In a box build factory, you could have an electronics factory, you can have battery factories. We really changed the game in this virtual engineering world. And now we're in the process of changing the virtual manufacturing world, specifically in high-tech products. And you'll notice that a lot of this is that high-tech products are pervasive. So these factories that we see, these high-tech factories actually do exist in the automotive companies. And one of our biggest, one of our big clients is a big electronics manufacturer that does a lot of the U.S.-based vehicles. And then we also have other electronics manufacturers all over the world that do the same technology. So this is tried and true technology. But I say again, it's very scalable to a small company all the way up to the biggest companies in the world.
Yeah, and having that planning and being able to improve that efficiency, like you're saying, Lou, with the digital twin, getting that full detailed picture of the process and optimizing that as part of the process, running it through those what ifs, and creating that product plan, and validating that prior to building stuff saves so much time and so much effort when it comes to being actually have product that is for sale online and through different vendors around the world. And just having that visualization process is priceless, as it would say. The product is at risk, and your profits are at risk if you're not meeting the go-to-market.
Yeah, I find that it's really dependent on the product they're building. I have some customers that build like cameras and stuff, and when you look at what's inside a camera, it reminds me of like opening a watch. There is so much technology in a camera and that little form factor. It's amazing to me that they can actually put it all together. I mean, I've seen rigid flex boards that go in different directions. I've seen so many flex cables, and you think about cell phones and that technology, the microscopic size of things. It's just crazy. And I think a lot of these things that you see here are offshoots of technology that people are invoking in factories today.
Yeah, it's the complexity that people take for granted because these products just work. Think of a Garmin smartwatch, if you will, or some of the dash cams and other stuff like that.
So just try to open a cell phone yourself. You'll be frightened. You'll never get it back together.
Yeah, no, I cracked the screen on mine not too long ago, and
we have customers that make 2 million cell phones a year using these solutions. So it's crazy when you look at some of this stuff, and you're just in awe sometimes when I get into a customer site and they show us what they're doing. I'm like, wow, just when I thought something was hard, they just made it even harder.
Yeah.
The latest ones are those foldable screens.
Yes. And
what's
the life cycle?
The life cycle is huge because there's a trick to them, and they used our solution to figure out the solution. But the biggest problem was manufacturing them, getting them positioned right. The trick is in the hinge. There's a minimum bend radius of the materials, so they're at like 2 to 3 times the min bend radius. So what they're doing is that they have a special hinge. But manufacturing and placement of the screen on the product is critical. It's insane.
I think the key takeaways, and these are some of the clients that you guys have worked with for decades in some instances, but some of the benefits that they've taken away from adopting these manufacturing process engineering, visualizing and validating. These are some of the metrics that they've achieved, and maybe you could comment on some of these.
So when we see this, we're typically seeing productivity in shifts. Is what we're seeing is that because we're able to optimize the product placement and even optimize things in engineering. You saw that little video where they're putting, it's typically a camera board, or that might be or an LED light backlit panel into the cell phone, and when they built it, it fits mechanically, but you can't actually put it in. So that little piece was causing a lot of time in the factory factory. It was a gate. And so by changing that, they're able to increase their production, also, maximize the quality. And, so some simple changes like that. So we typically see productivity going up because we've optimized how things are going together, smoother engineering of the product. When you say number of workers, that's really through the optimization. We don't see a lot of a huge amount of savings in the number of workers because the workers just get displaced into a different area. But what we have seen is the process creation going down in half on average. And I think here it's saying greater than 50%. But we're seeing to be able to set up a factory to build a product, typically we take a manufacturing engineering team about 12 days. And today we're seeing about 5. In some places it's much, much easier. And then when it's, SSOP, standing operating procedures, it's really saving about 25% because you have the materials right in front of you. And the other thing that's interesting is one of the things we didn't show is in the time scale is this all can be done concurrently with engineering because you have complete access to their data. So as they make changes, you can see that. And when the final bill of material is, you can do a delta bill of materials and quickly, almost like a quick snap of a finger, change out the parts that are making the end. So you really, really can optimize up front. It also allows you to have feedback to the engineering teams if you have an manufacturing engineer. So most companies have a manufacturing engineer who works with the engineering teams, but he would be a real full-time participant in the engineering process cycle. And then the scenarios of testing is it's really, we're reducing it to no time. You don't have to run dry runs, as they would say, or they call them low-rate production runs. What we're seeing is a lot of companies are really moving from to maybe they run a few tests in the morning to make sure that the equipment, feeders, and everything else are set up, and then we see the production coming right away for the product. So basically, you get really assured of what you're going to produce on the line very, very quickly. So these are really, and this is a mixture of our customer base, and these are solely manufacturing customers. Delmere is our manufacturing brand.
Yeah, the one thing that I find really interesting and surprising is that these processes are enabling collaboration and enabling a feedback loop from process engineering, manufacturing, and design engineering. So with that collaboration, we're compressing the amount of time that it takes to do product development.
Well, just like we tear down the walls between mechanical and electrical and electronics engineering, we're doing the same in manufacturing. Everybody to build a product today, you need to be fast, nimble, quick, and you cannot have the silos of yesteryear. So our whole goal is to remove the silos, get a free flow of information. At the end of the day, the customers win and the manufacturing and engineering teams win. And what I mean by customers, the quality levels of the products are much higher coming out of a process that's been engineered to be optimized versus something where there's rework and such. You can always tell the products that have been reworked in the manufacturing.
Yeah, and those, that's everything, especially on social media today. If your products aren't of the quality and durability that people are expecting, it's really going to have a negative effect.
Yeah, a lot of this is coming out of the gates. The gates, the bend gate of the phone that you put in your pocket and bend. We've got some stuff that came out of antenna gate where you put your hand on the antenna. So a lot of that stuff actually came out and helped us to optimize the engineering space or the electronic space because we were doing for automotive for years and aerospace for years, and they came to us and said, "Can you do the same thing so that we don't have antenna gate, we don't have bend gate, we don't have exploding batteries and that type of stuff." So we've really come really forward with it, and this is where a lot of that virtual engineering will bring up. Just think about it, if you had the battery winding and you saw how that was done and such, you would have been able to send the min-max conditions because you can do that in the software.
Fantastic.
Yeah,
that really explains well the entire process, this whole planning, visualizing, validating that we've been talking about today. And I'd just like to thank everyone for attending. If there's any questions that you might have or you'd like to get in contact with us, we'd be more than happy to get you more information, to direct you to videos and other applications, notes that you might find useful.
Absolutely. Thank you, Ed and Lou. So, yeah, at this time, we can open up the Q&A. If you have any questions, you can enter them now. And if we're unable to address any questions directly during the webinar, we will be in contact with you. So our first question is, we'll start off with a statement from Mitchell. Seems like an excellent way to basically lay out the plan of attack as far as material procurement and then mechanical assembly. For our company, we perform in-house tests with specific test SW. How can this tool be used to capture this side of the production process?
That's built into our DNA, absolutely, because basically the work structure. So what we do is we can do it either way. The work structure can be built from. We typically will build it from the engineering side and move it over, but we can build it on the other side because we do have customers that have dedicated lines and such. So I think in that particular case, I would definitely love to have a deep conversation, and we can show you how this actually can be optimized, because absolutely that's what we're here for, and that's totally what we do.
Yeah, the software part of it, Lou, is something that a lot of people ask about as well, and I think when they specifically what he was talking about was they have test software, and the test software could be for functionality on the board, but it could also be versions of software based on English or some other language.
No, absolutely. So that is part of our engineering bill of materials. So one of the latest things that we've been bringing in is software. So your software loads, it could be your configuration loads, and then we have a lot of customers today that use configured products, the software configured products or software feature-rich products. So the variants are driven by software. We treat software. We can treat software as a physical element, so that basically we can put it into the manufacturing bill of materials and actually assign it to be blown into it. We do that with cell phone manufacturers all the time. They have different versions of operating system they put on different versions of the phone. And so we will actually take the firmware load and put it into the product. So, and again, that's coming right from the engineering bill of materials. So we take that as a software item, but we put it in as a physical entity into the manufacturing side, because manufacturing really needs to have a touchy-feely type scenario where they understand that it's a physical entity. So we do a lot of that today, absolutely. Most products today, and especially specifically in automotive, it's really, really relevant where you see the vehicles. They're all built the same, and the only thing that may change that you're paying a couple $1,000s for is some software that's being put into the processor. So it's very common for us to see that.
Yeah, thank you. Our next question is, are these solutions available today?
Absolutely. These are off the shelf and proven. We have lots of big customers that run these solutions, and basically this is your first time maybe seeing them, because we're excited to be with EMA Design, but throughout the world we run these things in many factories. Most of the white goods manufacturers run this type of technology. And you're saying white goods, why white goods? Because have you seen a washing machine or a refrigerator or any kind of white goods without electronics in them anymore? So they really do run these type of systems, and even the air conditioning systems are now running with this technology. So we have a lot of the people in China and a lot in Taiwan and here in the States that are actually running this run this application.
The last question is, how does a virtual twin help me if I don't build in-house?
Well, it allows you to do fit up, finish, and actually to understand how your product is going to be put together by using the virtual twin. And you saw how we separated. That's why I showed the bill of materials. Bill of materials is critical. So really, the bill of materials is really showing you all the items that are in there. That's your product structure. Your engineering bill of materials is really your product structure. And as you put this together, you need to put the sequences together. So when you're thinking about it, you make sure you put it together properly. So that first shows you that you have all of the right items, and you can see that not just that you didn't skip anything in engineering or something's missing. The other piece is that we showed is the fit up and finish, is that we can also find collisions and clashes and such, so that if you are building product and you're doing the virtual twin, we can make sure that the jigsaw puzzle goes together ahead of time. And it's really interesting when you're doing like flex cables and you're doing multi-board assemblies, is really how to make sure that the clearances are there, and that the clearances are there that are beyond engineering clearances, that, you know, somebody with this size thumbs can actually put the circuit board into the place, or that you didn't put a memory expansion slot in a place that you can't get at, so that you need to make sure that you sequence the operation of putting it together. So we see a lot of that. We also see a lot of like sequencing where they're going to do testing, believe it or not, because sometimes they have hidden elements. Like a real example is memory, is that they'll put the memory deep inside the product, and it's a plug-in. If it comes loose on the plug-in and they put the whole assembly together, it could take them an hour to put it back together, and they may have to replace parts. So what a lot of people are doing is, in the sequencing, is putting testing to make sure that what they put together, in a case where you have blind mates or blind access, to make sure you build it right the first time, and make sure to put a step in to check it, and actually maybe have some testing done, you know, a go no go test at certain points, and you'll be able to see all that here. We have a lot of customers that people don't want field repairable units. They want to be able to do this, so they build all of this blind assembly stuff, and once it's assembled, it's a nightmare to take apart and put back together in the field.
Yeah, my oven is like that, Lou, and I know several other products for that. You know, you'd have to completely tear that thing down, and having that Wi-Fi plug-in that they can run diagnostics from it remotely is absolutely key. The other thing that I think really the digital twin helps is that level of collaboration. There have been several different instances where folks, you know, on the engineering side, thought, well, you know, that I didn't realize that, you know, with this cable harness, you know, the voltage was dropping, you know, a half a volt from one end of the product to the other end of the product, you know, and they had to bump up the size of the wire by a couple of gauges to make sure that they didn't have that voltage drop. That allowed them to do that simulation early on and really take advantage of that compressing of the time and getting it right the first time by that level of collaboration.
Yeah, there's so many different options with the virtual twin. Most of it is really about making sure the product is manufacturable. You can sequence the manufacturing, and then unfortunately, most MCAD systems, you can design things that are not manufacturable, very much so. I mean, we have lots of checking for gussets and machined and milled and parts, but when you start putting parts together with inside assembly, so you have a plastic bezel, and then you have a printed circuit board going in, and then you have all these different pieces, and you have drafting and changes in the plastics. You know, we can do the min-max tolerancing in this in the virtual world to make sure that you're going to be able to put it together. But you see a lot of that where customers are using the virtual to make sure that they can put it together, and as designed is manufacturable. It's amazing that flex cables can go 90 degrees sometimes. So people forget to put in service loops and that type of stuff. And with this virtual twin, you can actually see all that. And sometimes people forget that things actually have thickness. So when we're putting things together, we get a lot of collisions and such when we put things together. And anybody who says that that's really weird. I came from a factory world, and anybody who says that they don't have these problems is fibbing a little bit, because every once in a while, something gets misdone, and it's just the nature of the software. It's just the nature of mechanical CAD. It can look for clearances, but they have to be set. And once you start putting them together as a system of systems, you can actually see all the collisions and stuff. And that's one of the things the software will tell you, is that even when you're doing the work instructions, it'll tell you that you can't get here from there because you're going to have a collision.
Right. Awesome. Thank you so much, Lou.
Oh, you're welcome. And like I said, we're so excited to be with EMA as a partner. It's great to have you, representing us, and actually I'm looking forward to the journey and to the other side of the business.
Great place to be.
Yeah, absolutely.
Thank you, Ed and Lou. So before we sign off, I'd just like to reiterate that we will be sending everyone a recorded version of today's webinar with the presentation slides within the next few days. And I want to thank you all for joining us, and thank you, Ed and Lou.
Thanks, Brianna.